Hi guys, welcome back. We are going to pick up where we left off with the lesson 3.7 and talk about absolute value inequalities. So our objective for this lesson is that I can solve inequalities involving absolute value, and our essential understanding remains the same, where we can write an equivalent pair of linear equations or inequalities in order to solve them. So we're going to take a look at our key concept for this, solving absolute value inequalities. When we have an inequality that's in the form the absolute value of A is less than B, and B is a number that is greater than 0, we solve the compound inequality, the opposite of B, less than A, less than B, which is this one right up here. Okay, so it's going to be an AND. To solve an inequality in the form of the absolute value of A is greater than B, where A is the variable expression and B is greater than 0, we're going to solve the inequality A is less than negative B or A is greater than B. And the rules are the same for greater than or equal to inequalities. All right, so we're going to start off with problem number 4, which is addressing solving an absolute value inequality involving greater than or equal to. Now, at the beginning, our rule said that we can write it as one big compound inequality, and that's fine. We can also do the same thing as we did with our equals to inequalities, where we write them as two separate inequalities. And that's what my second box that I've added here tells us. So if we're less than b, we would write it as ax plus c is less than b. So just like the equation, we just dropped the absolute value bars and kept it the same. And then our second piece was ax plus c is going to be greater than negative b. So take the opposite of whatever b is, and whenever we take the opposite of something, we're dealing with negatives, we got to flip our inequality symbol. All right, so that makes sense. We're saying that the distance away has to be greater than or equal to 20. All right, so let's get to it. We've got, and actually I was pointing to the wrong example. We're doing greater than or equal to. So the bottom set of rows. All right, so let's separate it out. We have 5x is greater than or equal to 20. And you have 5x is less than or equal to negative 20. All right, so we're going to solve each of these the same way. We divide both sides by 5. So x is going to be greater than or equal to 4. Divide by 5. X is less than or equal to negative 4. So we're going to graph them as well. So remember, close dot for greater than or equal to. So we have close dot at 4, and we're going to be shading to the right. And we have a close dot at negative 4, and we are shading to the left. Okay, so when our absolute value is greater than a number, we are doing an OR equation, and they are going out from the center, going out. Okay, letter B. Same approach. Our absolute value has been isolated, so now we can split it into our two pieces. 2x plus 4 is greater than or equal to 5, and 2x plus 4 is less than or equal to negative 5. Subtract 4 from both sides of the equation, inequality. 2x is greater than or equal to 1. Divide both sides by 2. X is greater than or equal to 1/2. Second equation, we're going to subtract 4 from both sides. 2x is less than or equal to negative 9. Divide by 2. X is less than or equal to negative 9/2. So now we graph both of these. So we have a solid dot at 1/2, and we are shading to the right. And we have a solid dot at negative 9/2, which should be negative 4.5. And we are shading to the left. All right. Letter C, we have the absolute value of 3x plus 2 is greater than or 7. So we start by our absolute value is isolated. So we need to split it into our two pieces. 3x plus 2 is greater than 7. And 3x plus 2 is less than negative 7. So we start, subtract 2 from both sides of our equation. 3x is greater than 5. Divide both sides by 3. X is greater than 5/3. So if we go ahead and graph that right away, 5/3 is 1 2/3, so it's right about here. And it's an open dot, and we are going to shade to the right. The second part of it, subtract 2 from both sides. 3x is going to be less than negative 9. Divide both sides by 3. X is less than negative 3. So we have an open dot at negative 3. And we are shading to the left. Now, for these absolute value questions, each of your points, each of your dots will be the same. So if one of them is an open dot, they're both going to be an open dot. If one's a closed dot, they're both a closed dot. All right, so why don't you guys try the next two, and then come back and we'll talk about them. So 3x plus 4, absolute value is greater than or equal to 8. We have that one already isolated, so we can separate them into our pieces. 3x plus 4 is greater than or equal to 8. And 3x plus 4 is less than or equal to negative 8. So we're going to solve that. Minus 4, minus 4. 3x is greater than or equal to 4. Divide both sides by 3. X is greater than or equal to 4/3. On the other side, we're going to subtract 4 from both sides of our equation. 3x is less than or equal to negative 12. Divide both sides by 3. X is less than or equal to negative 4. So now we have a closed dot at negative 4. And we have a closed dot at 4/3. And we are going to shade both of these to the outside. So to the right for the 4/3 and to the left for the negative 4. All right. Moving on, we have letter B. Again, our absolute value is isolated, so we just need to deal with separating it out. So we have 2 minus 3x over 5 is greater than or equal to 2. We have 2 minus 3x over 5 is less than or equal to negative 2. Start off, we're going to get rid of the fraction, so we're going to multiply both sides by 5. So we're left with 2 minus 3x is greater than or equal to 10. Subtract 2 from both sides. Negative 3x is greater than or equal to 8. And we divide both sides by negative 3. And we get that x is going to be, oh, don't forget, dividing by a negative. So it's going to flip the inequality. X is going to be less than or equal to negative 8/3. All right, so that'll be closed out at negative 2 2/3 right there. All right, our other equation, we need to do the same thing. We're going to multiply by 5 on both sides of our inequality. 2 minus 3x is less than or equal to negative 10. Subtract 2 from both sides. Negative 3x, I'll kind of shift off to the side here, is less than or equal to negative 12. Divide both sides by negative 3. And x is going to be greater than or equal to 4. Close dot at 4, and we're shading to the outside. Make sure you guys remember when you are multiplying or dividing by a negative number, the action you are taking is multiplying or dividing by a negative number, we need to flip the inequality symbol. All right. Letter A for problem 5, which is involve absolute value inequalities involving less than or equal to. You could rewrite these as just a series, a 3-part inequality, compound inequality, or you can write them as 2 separate inequalities. So the first time, I'll write it as 2 separate ones. So we have 2n plus 1 is less than or equal to 9, and we have 2n plus 1 is greater than or equal to negative 9. All right, start off, we're subtracting 1 from both sides. 2n is less than or equal to 8. Divide by 2. N is less than or equal to 4. Okay. Our second equation, we subtract 1 from both sides. 2n is greater than or equal to negative 10. Divide both sides by 2. N is greater than or equal to negative 5. So we have a closed dot at negative 5. We have a closed dot at positive 4, and we are shading in between. That is our solution set. Okay. Letter B, first thing we need to do is isolate our variable, or not our variable, our absolute value. So we're going to add 1 to both sides. So the absolute value of 2x minus 7 is less than 1. Okay. So now we need to split this up and solve it. So I said we could leave it together. I'm going to just demonstrate the same process that we've been doing for each of these, which is split our absolute value into 2 separate tracks. So we've got 2x minus 7 is less than 1, and we have 2x minus 7 is greater than negative 1. So we start by adding 7 to both sides of our inequality, and then divide both sides by 2. So x is less than 4. Our other inequality, we're going to add 7 to both sides. 2x is greater than 6. Divide by 2. X is greater than 3. So we have x is going to be greater than 3 and less than 4. So we have an open dot at 3. We have an open dot at 4. And we are shading the space in between. Okay? All right. Moving on to our next section, word problems. So, of course I love word problems. Wonder what that star could mean. I don't know. Must be important. A food manufacturer makes 32-ounce boxes of pasta. Not every box weighs exactly 32 ounces. The allowable difference from the ideal weight is at most 0.05 ounces. Write and solve an absolute value inequality to find the range of allowable weights. All right, so let's look back at our problem. Important pieces of information. We've got 32-ounce boxes of pasta. We have an allowable difference, which tells us we're going to be subtracting from the ideal, is at most 0.05 ounces. And we are told we want to write an absolute value inequality to do this. All right, so we're going to have an inequality, and we have it less than or equal to 0.05, because the difference has to be less than that. Do we know our weight of our actual boxes? No. We know the ideal, so x minus 32 is going to be less than or equal to 0 or 0.05. So we solve these the way we have all others. X minus 32 is less than or equal to 0.05, and x minus 32 is greater than or equal to negative 0.05. So we add 32 to both sides, and x is less than or equal to 32.05. It's a word problem, so I need my units, ounces. The second one, add 32 to both sides, and x is going to be greater than or equal to 31.95 ounces. And this makes sense. It could be a half an ounce above our ideal, or what is that? 0.05 above, or we could have 0.05 below. 5 hundredths or 5 hundredths above, 5 hundredths below. And that's what we did there. We added those two together. Okay? All right, letter D. The tire pressure is measured in pounds per square inch, PSI. Tires should be kept within 2 PSI of the manufacturer's recommended tire pressure for them to be worn correctly and safely. The recommended inflation pressure for a tire is 30 PSI. Write and solve an absolute value inequality to find the range of allowable pressures. So again, we have the absolute value of x minus, what's my ideal? My ideal is 30. X minus 30 has to be less than or equal to 2. Okay, so the difference between our actual tire pressure and our ideal needs to be less than or equal to 2. So the absolute value is isolated, so I can write my two inequalities. X minus 30 is less than or equal to 2, and x minus 30 is less or greater than or equal to negative 2. All right, so we go and add 30 to both sides of our equation. X is less than or equal to 32. Do the same thing for our equation on the right. And x is going to be greater than or equal to 28. Don't forget your units, PSI for both of them. So your tire should be somewhere between 28 pounds per square inch on the low end and 32 pounds per square inch on the high end. And yeah, all right. Letter E, using the margin of error in the graph, write an inequality that represents the percentage of people who believe that we are doing enough to address climate change. So we need doing enough, and I see down over here that my margin of error is plus or minus 3.4. And doing enough is right there with 19%. So the absolute value of x minus 19 has to be less than or equal to 3.4. All right, absolute value is isolated, so we can separate it out right away. We have x minus 19 is less than or equal to 3.4. And x minus 19 is greater than or equal to negative 3.4. Add 19 to both sides of our equation, and x is going to be less than or equal to 22.4. And x is going to be greater than or equal to 15.6. So pay attention whenever they tell you what the margin of error is on something. Sometimes it could be quite significant. Sometimes it's not is quite insignificant. When they were doing presidential races, when they talk about an opinion poll, is there a difference between the two candidates between or within that margin of error? That means it's a dead heat, and either person could be ahead at that point. All right. Now I did say you could write these as one inequality, and I'll just show you that real quick down at the bottom here. We have x minus 19 is less than or equal to 3.4. But you'll remember we can read this the other way. X minus 19 is greater than or equal to. So as we read right to left, x minus 19 is greater than or equal to negative 3.4. So on the inequalities where you have less than or equal to, like problem 5, what you could do is you could set it up as this compound inequality, and then you would just be adding 19 to your 3 pieces like we did the other day, and you would get the same results. You would have 15.6 is less than or equal to x, which is less than or equal to 22.4. All right. If you're worried that you're going to get the two mixed up and you're going to make a mistake, write the two separate equations every time. You're really not doing all that much more work. It's just a different way of writing it. Okay. So fill out your level of understanding 1 through 4, and this one will be specifically just for the absolute value inequalities, since you already rated yourself for equations. And do make sure you fill out the summary. The summary I want you to fill out for the entire lesson 3.7. So both inequalities and equations. And there's a lot of approaches that are similar for both of them. Okay? Make sure you write down any questions you might have, and we will see you in class. Have a great night.